Albert Einstein, a comprehensive biography.
Albert Einstein was born on March 14, 1879, in Ulm, in the Kingdom of Württemberg in the German Empire. He was the first child of Hermann Einstein, a salesman and engineer, and Pauline Koach. The family moved to Munich in 1880, where Hermann and his brother Jakobe founded Elektrotechnische Fabrik J. Einstein, N.C., a company that manufactured electrical equipment based on direct current. Einstein's early education took place at the Luitpold Gymnasium in Munich, where he showed an exceptional aptitude for mathematics and physics. However, he struggled with the rigid and authoritarian educational system. In 1894, the Einstein family moved to Italy, and Albert continued his education at the Swiss Federal Polytechnic in Zurich, where he focused on physics and mathematics. He graduated in 1900, earning a diploma to teach these subjects. After graduation, Einstein struggled to find a teaching position and eventually took a job as a patent examiner at the Swiss Patent Office in Bern in 1902. This seemingly mundane job provided Einstein with ample time to explore and develop his scientific ideas. During his time at the Patent Office, he published several groundbreaking papers that would change the course of modern physics. In 1905, often referred to as Einstein's Annus Mirabilis or Miracle Year, he published 4 seminal papers in the Annalen der Physik. These papers included the theory of special relativity, the photoelectric effect, Brownian motion, and the equivalence of mass and energy, encapsulated in the famous equation E=mc². These contributions earned him widespread recognition and laid the foundation for modern theoretical physics. Einstein's work on the theory of general relativity, published in 1915, further cemented his status as a scientific luminary. This theory provided a new understanding of gravity as the curvature of spacetime caused by mass and energy. General relativity was experimentally confirmed in 1919 during a solar eclipse, which showed the bending of light from stars as it passed near the sun. This validation propelled Einstein to international fame. Later life. In 1914, Einstein moved to Berlin, where he became a professor at the Prussian Academy of Sciences. However, the rise of the Nazi regime in Germany forced him to emigrate to the United States in 1933. He accepted a position at the Institute for Advanced Study in Princeton, New Jersey, where he continued his research until his retirement. Throughout his life, Einstein was not only a scientist, but also a passionate advocate for civil rights, pacifism, and Zionism. He was deeply concerned about the ethical implications of scientific advancements, particularly the development of nuclear weapons. Despite his early support for the Manhattan Project, he became an outspoken critic of nuclear arms after World War II. Einstein continued to work on theoretical physics, including his quest for a unified field theory, until his death on April 18, 1955. His contributions to science have had a profound and lasting impact on our understanding of the universe. Einstein's name has become synonymous with genius, and his theories continue to influence and inspire scientists to this day. Albert Einstein's life and work represent a monumental achievement in the history of science. His revolutionary ideas reshaped our understanding of space, time, and energy, and his contributions to theoretical physics remain foundational to modern science. Einstein's legacy extends beyond his scientific achievements, encompassing his humanitarian efforts and his enduring influence on both the scientific community and popular culture. Albert Einstein, a biography of his greatest achievements. Despite facing challenges in the rigid educational system, he pursued his passion for science and ultimately earned a diploma in physics and mathematics from the Swiss Federal Polytechnic in Zurich in 1900. The Miracle Year, 1905. Einstein's most notable achievements began to emerge in 1905, a year often referred to as his Annus Mirabilis, or Miracle Year. During this period, while working as a patent examiner in Bern, Switzerland, he published 4 groundbreaking papers in the journal Annalen der Physik. These papers transformed our understanding of the physical world and laid the foundation for modern theoretical physics. 1. Theory of special relativity. In his paper on the electrodynamics of moving bodies, Einstein introduced the theory of special relativity, which fundamentally changed our understanding of space and time. The theory proposed that the laws of physics are the same for all non-accelerating observers, and that the speed of light is constant, regardless of the observer's motion. This work challenged the classical Newtonian mechanics and introduced the famous equation E equals mc2, which demonstrates the equivalence of mass and energy. 2. Photoelectric effect. In his paper on a heuristic viewpoint concerning the production and transformation of light, Einstein proposed the quantum theory of light, explaining the photoelectric effect. He suggested that light is composed of discrete packets of energy called quanta, or photons, which can be absorbed or emitted by electrons. This work provided crucial evidence for the emerging field of quantum mechanics, and earned Einstein the Nobel Prize in Physics in 1921. 3. Brownian motion. In his paper on the movement of small particles suspended in a stationary liquid, Einstein provided a theoretical explanation for Brownian motion, the random movement of particles suspended in a fluid. His work confirmed the existence of atoms and molecules and supported the atomic theory of matter. 4. Mass-energy equivalence. Einstein's equation E equals mc2, introduced in his special relativity paper, demonstrated that mass and energy are interchangeable. This profound insight had far-reaching implications for physics and laid the groundwork for the development of nuclear energy and atomic power. Theory of general relativity. Einstein's work on the theory of general relativity, published in 1915, is considered one of his greatest achievements. This theory extended the principles of special relativity to include gravity, providing a new understanding of gravity as the curvature of spacetime caused by mass and energy. General relativity replaced Newton's law of universal gravitation and offered a more accurate description of gravitational phenomena. The theory's predictions were confirmed in 1919 during a solar eclipse, when the bending of light from stars passing near the Sun was observed. This validation catapulted Einstein to international fame and solidified his status as one of the greatest scientists of all time. Legacy and impact. Albert Einstein's contributions to science have had a profound and lasting impact on our understanding of the universe. His theories of relativity revolutionized the field of physics and changed the way we perceive space, time, and gravity. His work on the photoelectric effect in quantum theory provided crucial insights that laid the foundation for the development of quantum mechanics. Einstein's legacy extends beyond his scientific achievements. He was a passionate advocate for civil rights, pacifism, and Zionism, and he used his platform to promote social justice and humanitarian causes. Despite his early support for the Manhattan Project, he later became an outspoken critic of nuclear weapons and advocated for disarmament. Albert Einstein's name has become synonymous with genius, and his contributions continue to inspire and influence scientists, researchers, and thinkers around the world. His work has shaped the course of modern science and technology, and his ideas remain foundational to our understanding of the natural world. Albert Einstein and his scientific nemesis. Albert Einstein, one of the greatest scientific minds of the 20th century, revolutionized our understanding of the universe with his groundbreaking theories of relativity and quantum mechanics. However, even geniuses have their rivals, and in Einstein's case, one of his most prominent scientific nemeses was the Danish physicist Niels Bohr. Their intellectual rivalry, which centered around the nature of quantum mechanics, not only shaped the course of modern physics, but also gave rise to some intriguing and spooky theoretical debates. The rivalry between Albert Einstein and Niels Bohr began in the 1920s. During the early development of quantum mechanics, Bohr was a key figure in the Copenhagen interpretation of quantum mechanics, which posited that particles do not have definite properties until they are observed. This interpretation introduced the concept of wave-particle duality and the idea that the act of measurement collapses a particle's wave function into a definite state. Einstein, on the other hand, was deeply uncomfortable with the inherent randomness and indeterminacy of quantum mechanics as proposed by Bohr. Einstein believed in a deterministic universe where physical laws were predictable and exact. He famously remarked, "God does not play dice with the universe," expressing his skepticism towards the probabilistic nature of quantum mechanics. Their debates reached a climax at the Solvay conferences in the 1920s and 1930s, where Einstein and Bohr engaged in a series of profound and often contentious discussions about the nature of reality and the completeness of quantum mechanics. These debates, known as the Bohr-Einstein debates, were pivotal in the development of quantum theory and highlighted the fundamental philosophical differences between the two scientists. The spooky theory. Quantum entanglement. One of the most intriguing and spooky aspects of the Bohr-Einstein debates was the concept of quantum entanglement. In 1935, Einstein, along with his colleagues Boris Podolsky and Nathan Rosen, published a paper known as the EPR paradox, Einstein-Podolsky-Rosen paradox. The EPR paradox challenged the Copenhagen interpretation and suggested that quantum mechanics was incomplete. The EPR paradox posited that if two particles become entangled, the measurement of one particle's properties would instantaneously determine the properties of the other particle, regardless of the distance between them. This phenomenon, which Einstein famously referred to as spooky action at a distance, seemed to violate the principle of locality, which states that objects are only influenced by their immediate surroundings. Bohr responded to the EPR paradox by arguing that quantum entanglement did not imply any faster-than-light communication between particles. Instead, he maintained that the properties of entangled particles were inherently linked, and that the act of measurement itself played a crucial role in determining their states. This idea further solidified the Copenhagen interpretation, despite Einstein's persistent objections. The intellectual rivalry between Einstein and Bohr had a profound and lasting impact on the field of quantum mechanics. While Einstein's deterministic view ultimately gave way to the probabilistic nature of quantum mechanics, his critiques in the EPR paradox sparked ongoing research and debate. Quantum entanglement, once considered spooky, has now become a well-established and experimentally verified phenomenon. In recent years, advancements in quantum information science have leveraged the principles of entanglement for practical applications, such as quantum computing and quantum cryptography. These developments highlight the significance of the debates between Einstein and Bohr, as their discussions continue to influence cutting-edge research and technology. Albert Einstein and Niels Bohr's rivalry was not merely a clash of personalities, but a profound and philosophical debate about the nature of reality and the completeness of physical theories. The spooky concept of quantum entanglement, born out of their intellectual conflict, has become a cornerstone of modern quantum mechanics. This enduring legacy underscores the importance of their contributions to science and reminds us that even in disagreement, great minds can collectively advance our understanding of the universe. Imagine a world without Albert Einstein's discoveries. Imagining life without E equals mc. Albert Einstein's groundbreaking equation, E equals mc, has had a profound impact on our understanding of the universe and the development of modern technology. This equation, which demonstrates the equivalence of mass and energy, has far-reaching implications in fields ranging from nuclear physics to cosmology. Imagining a world without Einstein's discovery, and the absence of E equals mc2, allows us to explore how different our scientific knowledge and technological advancements might be today. Impact on nuclear energy and technology. One of the most significant applications of Einstein's equation is in the field of nuclear energy. The equation E equals mc squared reveals that a small amount of mass can be converted into a large amount of energy. This principle is the foundation of nuclear fission and fusion, which are the processes that power nuclear reactors and atomic bombs. Without Einstein's discovery, the development of nuclear energy would have been delayed, if not entirely absent. The absence of nuclear reactors would mean a heavier reliance on fossil fuels for electricity generation, leading to increased carbon emissions and a greater impact on climate change. Additionally, the absence of nuclear weapons would have altered the course of history, particularly during World War II and the Cold War, potentially resulting in different geopolitical dynamics and conflicts. Advancements in medical and scientific fields. Einstein's equation has also played a crucial role in medical advancements, particularly in the field of medical imaging. Technologies such as positron emission tomography, PET scans rely on the principles of nuclear physics and the conversion of mass into energy. Without E equals mc squared, the development of these advanced imaging techniques would have been hindered, limiting our ability to diagnose and treat various medical conditions. In the realm of scientific research, Einstein's equation has been fundamental to our understanding of particle physics and the behavior of subatomic particles. The discovery of antimatter, the development of particle accelerators, and the exploration of high-energy physics all rely on the principles outlined in E equals mc squared. Without this knowledge, our understanding of the fundamental building blocks of the universe would be significantly limited. Cosmology and our understanding of the universe. Einstein's theories of special and general relativity, of which E=mc² is a crucial component, have revolutionized our understanding of the cosmos. The equation has provided insights into the behavior of stars, black holes, and the expansion of the universe. Without Einstein's contributions, our knowledge of cosmology and astrophysics would be drastically different. The concept of mass-energy equivalence is essential in understanding the life cycles of stars, including processes such as stellar nucleosynthesis and supernova. The absence of Einstein's discoveries would hinder our ability to explain these phenomena and limit our comprehension of the origins and evolution of the universe. Albert Einstein's equation E=mc² has had a profound and far-reaching impact on science, technology, and our understanding of the universe. Without this discovery, the development of nuclear energy, medical imaging, particle physics, and cosmology would be significantly hindered. Our world would be vastly different, with slower technological progress, limited scientific knowledge, and altered historical events. The absence of E=mc² serves as a reminder of the importance of Einstein's contributions to modern science and the lasting legacy of his groundbreaking work. The awards and honors of Albert Einstein. Albert Einstein, one of the most influential physicists of the 20th century, has made groundbreaking contributions to science that earned him numerous awards and honors throughout his career. His work in theoretical physics, particularly his theories of relativity and contributions to quantum mechanics, has revolutionized our understanding of the universe. The various awards and highlighting the significance of each recognition in the context of his illustrious career. Nobel Prize in Physics 1921. The most prestigious award Einstein received was the Nobel Prize in Physics in 1921. He was awarded the prize for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect. The photoelectric effect, which demonstrated that light could be understood as both a wave and a particle, provided crucial evidence for the emerging field of quantum mechanics. Although Einstein is perhaps best known for his theory of relativity, it was his work on the photoelectric effect that earned him the Nobel Prize, underscoring the breadth of his contributions to physics. Copley Medal 1925. In 1925, Einstein was awarded the Copley Medal by the Royal Society of London. The Copley Medal is one of the oldest and most prestigious scientific awards, given for outstanding achievements in scientific research. This honor recognized Einstein's extensive contributions to theoretical physics, including his work on relativity and quantum theory. Receiving the Copley Medal placed Einstein among the ranks of other distinguished scientists who had made significant advancements in their respective fields. Gold Medal of the Royal Astronomical Society 1926. The following year, in 1926, Einstein was awarded the Gold Medal of the Royal Astronomical Society. This award acknowledged his contributions to our understanding of the cosmos, particularly his theory of general relativity, which provided a new framework for understanding gravity and the structure of the universe. The Gold Medal is one of the highest honors in the field of astronomy, and Einstein's receipt of this award highlighted the profound impact of his work on the study of the universe. Max Planck Medal 1929. In 1929, Einstein received the Max Planck Medal from the German Physical Society. This medal is awarded for extraordinary achievements in theoretical physics and is named after Max Planck, the founder of quantum theory. The award recognized Einstein's pioneering work in both relativity and quantum mechanics, solidifying his status as one of the foremost theoretical physicists of his time. Honorary doctorates and other honors. Throughout his career, Einstein received numerous honorary doctorates from prestigious universities around the world. These included honorary degrees from the University of Geneva, 1909, the University of Rostock, 1919, Princeton University, 1921, the University of Manchester, 1921, the University of Madrid, 1923, the University of Paris, 1929, and Oxford University, 1931, among others. These honors reflected the global recognition of Einstein's contributions to science and his influence on the academic community. Einstein was also admitted to various esteemed scientific societies and received several other accolades. In 1923, he was admitted to the Order pour la, one of the highest honors in Germany. Additionally, He received the Benjamin Franklin Medal from the Franklin Institute in Philadelphia in 1935, recognizing his contributions to science and technology. Albert Einstein's numerous awards and honors are a testament to his extraordinary contributions to science. From the Nobel Prize in Physics to the Copley Medal and the Max Planck Medal, each award highlighted different aspects of his groundbreaking work in theoretical physics. Einstein's legacy continues to inspire scientists and researchers around the world, and his achievements remain a cornerstone of modern scientific understanding. Albert Einstein is primarily known for his theoretical contributions to physics, rather than for inventing practical devices. However, he did hold a few patents for inventions, some of which have had lasting impacts. Here are a couple of notable inventions that Einstein patented. 1. Einstein refrigerator. In collaboration with his former student Leo Szilard, Einstein developed an absorption refrigerator that used no moving parts and operated at constant pressure. This refrigerator was patented in 1930. Although it was not widely adopted at the time, the principles behind it have influenced modern refrigeration technology. 2. Sound reproduction system. Einstein, along with Rudolf Goldschmidt, patented a system for sound reproduction. This invention aimed to improve the quality of sound recording and playback, contributing to the development of audio technology. While these inventions are not as widely recognized as his theoretical work, they demonstrate Einstein's diverse interests and his ability to apply his scientific knowledge to practical problems. Albert Einstein had 3 children with his first wife, Mileva Merrick. First, Lieserl Einstein. Born in 1902, Lieserl's fate remains somewhat mysterious. Some sources suggest she may have died in infancy, while others speculate she was given up for adoption. Second child being Hans Albert Einstein. Born in 1904, Hans Albert became a prominent engineer and professor. He made significant contributions to the field of hydraulic engineering and had a successful academic career. His last child, Edward Tet Einstein. Born in 1910, Edward showed promise as a scholar, but struggled with mental health issues, including schizophrenia. He spent much of his life in psychiatric institutions and did not achieve the same level of professional success as his brother. Einstein also had 2 stepdaughters, Margot and Ilse, from his second marriage to Elsa Einstein. He was known to be a loving father and maintained close relationships with his children and stepdaughters throughout his life. After Albert Einstein passed away on April 18, 1955, his scientific legacy continued to influence and shape the world of physics and beyond. Unlike Nikola Tesla, whose work was seized by the U.S. government, Einstein's work was preserved and disseminated through various channels. Preservation and dissemination of Einstein's work. 1. Einstein's papers. Einstein's extensive collection of scientific papers, correspondence, and personal documents were carefully preserved. The Einstein Archives at the Hebrew University of Jerusalem house a significant portion of his papers, which were donated by Einstein himself. These archives contain thousands of documents, including unpublished manuscripts, letters, and notebooks, providing valuable insights into his thought processes and scientific contributions. 2. Publications and research. Einstein's published works, including his seminal papers on the theory of relativity, quantum mechanics, and other areas of physics, continue to be studied and cited by researchers worldwide. His theories have been validated through numerous experiments and have become foundational to modern physics. The continued study and application of his work have led to advancements in various fields, including cosmology, particle physics, and gravitational wave research. 3. Educational impact. Einstein's contributions to science have had a profound impact on education. His theories are taught in physics curricula at universities and schools around the world. Textbooks and educational materials often include detailed explanations of his work, ensuring that future generations of scientists and students can learn from his discoveries. The fate of Einstein's brain. One of the more unusual aspects of Einstein's legacy is the story of his brain. After his death, the pathologist Thomas Stultz Harvey conducted an autopsy and removed Einstein's brain without the permission of his family. Harvey preserved the brain and conducted studies on it, hoping to uncover the secrets of Einstein's genius. Over the years, pieces of Einstein's brain were distributed to various researchers for study. While some findings suggested differences in the structure of his brain, the scientific community remains divided on the significance of these observations. Albert Einstein's work has been meticulously preserved and continues to inspire and influence the scientific community. His theories and discoveries remain integral to our understanding of the universe, and his legacy is celebrated through education, research, and the preservation of his papers. While the story of his brain adds an unusual twist to his legacy, it does not overshadow the monumental impact of his contributions to science. Hit like, comment, and subscribe.